Every living thing on Earth shares a connection to the deep past. The trees outside your window, bacteria in the soil, whales in the ocean, insects, mushrooms, and every human being alive today all use related biological machinery. Our cells store information in DNA. They build proteins using similar molecular instructions. They rely on many of the same basic chemical processes. That commonality strongly suggests that all known life descends from an ancient shared population. But somewhere before that shared ancestry, something extraordinary happened. Non-living chemistry became biology. Molecules began copying information. Boundaries formed. Chemical reactions became organized. Systems appeared that could maintain themselves, reproduce, and evolve. Scientists study possible pathways for this transition under the field known as abiogenesis. There are promising ideas. Some research focuses on shallow pools, where wet and dry cycles could have concentrated organic molecules. Some looks at hydrothermal vents on the ocean floor, where heat and mineral gradients may have supplied energy. Other work examines how RNA-like molecules might have stored information and helped chemical reactions occur before DNA and proteins took over their modern roles. But no laboratory has recreated the full path from simple chemistry to a self-sustaining organism exactly as it happened on early Earth. We know life appeared. We do not yet know how likely that appearance was. This uncertainty creates two completely different possibilities. In the first possibility, life begins easily whenever conditions are suitable. Give a rocky planet liquid water, useful chemistry, and enough time, and sooner or later something starts reproducing. If that is true, microbial life may be widespread. It could exist beneath the ice of ocean moons, under the surface of Mars, in warm layers of distant atmospheres, or on worlds we have not yet discovered. The universe could be alive in a quiet, microscopic way. In the second possibility, the origin of life requires an extremely unlikely sequence of events. Perhaps the right molecules must appear in the right place, in the right order. Perhaps most planets produce organic chemistry but never cross the threshold into evolution. If that is true, Earth may represent a rare accident. The fact that life appeared relatively early in Earth's history is often used as evidence that life begins easily. Earth formed about 4.5 billion years ago. Evidence suggests life was present by at least 3.5 billion years ago, and possibly earlier, although the oldest claims are difficult to confirm. That sounds fast. But there is a selection effect hidden inside the argument. We are here to observe a planet where life began early enough for intelligence to evolve before the sun made Earth uninhabitable. If life usually takes 8 billion years to begin, observers like us would not appear around a star that remains stable for only a limited time. We could only find ourselves on one of the lucky planets where the process started early. So our own existence makes early life on Earth interesting but not conclusive.